Hi, welcome to chapter 3 and starting out with Python. So, in this chapter, we're going to go over decision structures and Boolean logic. Uh, this is really a key essential for programming. And the reason why it's a key essential is because without them, our programs would then execute from beginning to end or from top to bottom without any real control. You'd have no way to say, hey, if you find this to be true, then do this piece of code versus if you don't find it true, do this piece of code. And so your code essentially would run the same way every single time. And oftentimes we don't really consider that a really valuable program. It just does the same thing over and over again. And don't get me wrong, we can sometimes have that need, but most of the time, to add value to our programs, we want that ability to manipulate the code, change things up based on conditions that come along. So in this chapter, we're going to talk about that and really dive into that. So come on, let's strap in, let's do this. So we already talked about the fact that we're going to go over some condition statements, and those are known as the if statement, also the if else statement. We are going to talk about comparing strings, which is a big part of if statements. We want to be able to see if one string equals another string. We're going to talk about nested decision structures and the if else statement. We will talk about logical operators and Boolean variables, but we won't go over the turtle graphics. Again, as I said in previous chapters, that's all on you. If you want to take and look at that, it's a lot of fun actually. But unfortunately, this course really does not focus on the turtle graphics. So when we talk about if statements, we have three types of if statements. We have this control structure, which is a logical design that controls order in which set of statements execute. We have a sequential structure, which is a set of statements that execute in the order they appear. And then we have decision structure, which is specifically actions performed only if a condition exists. So this sequence structure is what we have thus far, right? So we have this. Oh, I guess my pen is not on. Here we go. This sequence structure is kind of what we've seen so far, which is a set of statements that execute in the order they appear. We want to start talking about the decision structure, which is specific actions performed only if a condition exists. We also see some control structure as well, which is logical design that controls order in which a set of statements execute. So, based on our if statements, we will have this logical design that will decide which set of statements to execute. Now, in a flowchart, the diamond represents a true-false condition that must be tested. So, what we're talking about, and you'll see here in the next slide, is the diamond, and actions can be conditionally executed. So, they are going to anything in this structure. If it's true, if this is true, then this code will be executed. And I'm sorry, let me rephrase that because typically in design, when we're drawing these out, the straight down code is oftentimes the false. So this is kind of the standard code line, the bit of code that is going to execute no matter what. And this is the true branch. And so we'll run some code here and then return back to that block of code. Now, with this, again, this true is that conditional set of code that we talked about here. It's definitely a control structure as well as a decision structure, right? We are going to do specific actions performed only if a condition exists. So again, if this condition exists, we're going to do this code. If it doesn't exist, then we're not going to do any additional code. We're going to go right back to the standard code line. Single alternative decision structure provides only one alternative path of execution. So what I've drawn here, is a single alternative decision structure. There is only one decision, and if that decision is true, only one condition will exist. If it's not true, then we're going to exit the structure, which is, again, we're basically going to return back to the standard set of code. So looking at this is very much what I just drew. So is it cold outside? And we'll put a little question mark, because that's what essentially we're saying when we put a diamond is we're asking a question. Is it cold outside? If it's true, then we want to make sure we wear a coat. Because if it's not true, then we're not going to do this extra piece of code. In fact, we're just going to go back to whatever we were doing. So maybe this is go to the park, right? Well, if it's cold outside, we should put a coat on first, then go to the park. If it's not cold outside, we can go straight to the park. So how does that look in Python? In Python, we say the keyword if, then we put a space, and then the condition with the colon at the very end. And it is a colon, it is not a semicolon, so this is a semicolon, right? That's not what we're talking about. We are talking about the colon. And then our statements are tabbed in. Now, let me take a moment to explain this, because this is where I see a lot of people have a lot of problems. So let me put my eraser on here and get rid of some of this extra stuff, because we're going to really focus a moment on the tabs. All right, so a lot of programming languages have different ways of saying that a piece of code is part of the condition. So these statements are a condition of this if statement. So if this is true, then we're going to do these statements. If it's false, it's going to skip those statements and go to wherever the next set of code is. And the reason why that's important to understand is because to specify that this block of code is the condition, in Python, we use a tab. So as you can see, this line of code is there, and then this line of code is indented. And when we're done with the conditional code, we'll undent, we'll go back to the original indent and start writing our code again. Okay? This happens a lot where people don't either they don't tab in their condition, or they don't tab in correctly. Like maybe on this they put one tab. Whoop. So this is one tab, and then they accidentally put two tabs here. This is going to cause you problems in your code. The code may run but not work the way you want it, or it may not run because it's going to be like, it's going to say, well, why is this statement tabbed in twice? So be careful when you're tabbing your stuff. And remember, again, when you're done with your conditional statement, you want to untab or remove and go back to the original tab line. Now, this is going to be even more confusing, because it's probably confusing now. We're going to see it here in a moment, but it's going to become a little bit more confusing when we talk about nested if statements. So hold on, we'll get to that in a moment. And but again, understand that there has to be a tab, and we're talking a single tab for each of the conditional statements under the if statement. And we have to have the colon. So the first line, known as the if clause, includes the word if. That's really important, as you can see here, followed by the condition. Now, if the condition is true, it's going to execute this code. If it's false, it will ignore this code and go to the first line after the condition. Okay? Now let's talk briefly about Boolean expressions and relational operators. A Boolean expression is an expression that's tested by an if statement to determine if it's true or false. I always tell people it's really kind of valuable to think about this as if you're asking a question. Is A greater than B? If it is, then it's true. If it's not, it's false. So always get in the habit when you're writing these conditions to ask yourself this like it's a question. If A is greater than B, it's true. Or sometimes I'll even say, is A greater than B? Yes? Okay, it's true. Great. Now, this whole statement is the Boolean expression. This actual symbol is the relational operator. So it determines whether a specific relationship exists between two clauses. So, as we know, that's greater than. We are familiar with less than. Well, let's talk about a couple more. So we have Boolean expressions and relationship operators. This one says, is it greater than or equal to? And this one is less than or equal to. Again, it's important to understand what the difference is between these operators. So we want to know the difference between these operators and these operators. These operators are known as exclusive operators, and this set of operators is known as inclusive operators. And the reason being is when we use these, we don't include the number we're comparing. So if we say, is A greater than 10, if A is equal to 10, this will not be true because it's not greater than 10. If we say, is A greater than or equal to 10, then yes, this is true. So that's why this is exclusionary, because we're going to exclude the number that we're comparing. And this is inclusionary because we're going to include the number we're comparing. So it is enough for one of the relationships to exist for the expression to be true. Now, the next one is something equal? To do the equal, we have to have two equal signs. And the reason being is one equal sign assigns. So if you're assigning a value to a variable, we use one equal sign. If we're comparing a variable to a variable, we use the is equal to, and that is 2. And I always keep it in mind, is I always remind myself that this is called the is equal to. Is equal to. And the fact is, because it's is equal to, it has to be more complex than just one equal sign, right? It's just the two equal signs. Again, 3 words helps me remember that it's 2 equal signs. That may not work for you. That's just one of the ways I've always remembered it. And then the opposite of that is the is not equal to. And the bang, some people call it an exclamation point, is what tells us that this is being referred to as the not equal to. So here is a quick Boolean expression relationship operator table. And I want you to take a moment on your own to kind of go through this. It's in the slide deck. You can pause this video if you want right now and just kind of read through these. I don't want to go too much into detail, but always remember that the expression is a question mark. In fact, you can see how all of these have the questions on the end. So remember that as you're going through. So remember, what's in our diamond is the Boolean expression. And within the Boolean expression is going to be the relational operator. Now, looking at this example, would 50,000, would this be true or false? If sales equals 50,000, And see, I only use one equal sign because I'm assigning 50,000 to sales. Would this be true or false? If you said false, you're right, because we're using an exclusionary relationship operator. 50,000 is not greater than 50,000. It's equal to 50,000. So keep that in mind. Any relational operator can be used in a decision block. So, and we're saying in this one, if balance is equal to 0, if payment is not equal to balance. And look, we've got two variables here in our condition statement. And that's okay. We can use variables in our condition statement. And most of the time, your Boolean expressions will be using variables. Again, that's what is powerful about programming is we can assign different values into these variables so our program runs slightly different every single time. It is possible to have a block inside another block. We can have an if statement inside a function. We can have statements in inner blocks must be independent with respect to the outer block. So again, what we're saying on that is we can have an if statement. Whoop. Sometimes the pen goes a little crazy. We can have an if statement. Here's our condition. And then here is our conditional code. And in our conditional code, we can have another if statement, but that means we've got one tab here, and we'll need two tabs here, because, oh, and by the way, the if statement, because it's part of the conditional code, also is tabbed in once. But when we're done with this conditional statement, we'll go back to only one tab. This might be a little confusing now. You will get the hang of it as you start to code and see some examples. If you really struggle with this, just reach out to me, let me know, and we can go through it. All right, so we're going to stop the video here so that way we can come back and talk about the if-else statement. I'll see you in a moment.